Hi, it's Mr. Bennett. In this video, what we need to talk about is we need to talk about scientific investigations. Now, investigation is just another word for experiments. So we're talking about experiments and how to set up an experiment in a way that makes it scientific. Now, before we get into that, let's review real quick what the purpose of an experiment is. And the purpose of investigations or experiments that we do in science is to mainly test a hypothesis. So you remember in our last video, a hypothesis is a possible explanation for something that we observe. Well, the purpose, not all hypotheses are correct. Some are right, some are wrong. How do we tell the difference? Well, we do an investigation or we do an experiment to show if that hypothesis is correct or not. Now, sometimes we do experiments to test a hypothesis. Sometimes we do an experiment just to see what's going to happen, that we have absolutely no clue what's going to go on. So sometimes we do investigations just to see what will happen, because we're pushing our knowledge so far, we can't even predict what's going to happen. Example, when the United States set off the first atomic bomb, the guy who was in charge of it, Oppenheimer, he was taking bets on whether or not the bomb would set the Earth's atmosphere on fire and kill everyone on the planet. They didn't know. They could not predict what an atomic bomb would do, and so they had to set one off to see what would it do. And so sometimes we do investigations just to see what will happen. Now, in order to make your investigation scientific, remember, it isn't just good enough to go out and screw around and say you're doing science. In order for your investigation to count as being part of science, to be part of scientific, there are some characteristics that it needs to have. First one we got going on is you must record data. If you do an investigation and you don't record any data, you really didn't do anything, because data is the language of science. Data is how we prove or disprove the hypothesis. So we've got to write down some data. And then the other big thing we got going on is someone else doing the same experiment should get the same results. Until you do an experiment in a way so that someone else doing the exact same thing gets the exact same results, you're not really doing science. And so that's an important thing to keep in mind, because remember, science has to be repeatable. If we don't get the same results time after time after time, we can't predict what's going to happen, and we can't use that in order to help people out. Okay, so let's go through and let's talk about how you set up an investigation. Now, the investigation or experiment you're going to do should always relate back to a question. So whenever we talk about an experiment, there's always the question that experiment is supposed to answer. So let's start out with a question. Here's a question for you. Gatorade, does it make you run faster? You see all these commercials that claim that Gatorade will make you a better athlete, make you better at sports, so on and so forth. So that's a real question. Well, this is something that we can actually test with science. How would we do this? Pretty simple. Have two people run a race. There you see two people running a race. Give one of the people Gatorade, and before the race, and give the other person water. Done and done. That would be a very simple investigation we could do to show if Gatorade makes you run faster or not. Now, how we did this is we manipulated things. We changed it. We only gave one of the two people Gatorade. We gave the other person water. And so that way, when they run a race, if the person who drank the Gatorade run faster, then we can say that, hey, Gatorade makes you run faster. Now, what we did right there is we set up what's called a manipulated variable, and this is something you absolutely positively have to know about investigations. That investigations have different variables or different things that are changing during the investigation. Now, the first one we're talking about is the manipulated variable, and from here on out, anything that you see written in purple is referring to the manipulated variable. The manipulated variable is the thing you change in your investigation. Now, one thing that's important to know about a manipulated variable is there should only be one different thing or one thing that you change between the different things that you're testing in your investigation. So in this case, the thing that was different, one person got Gatorade, the other person got water. That would be called a manipulated variable. That is what we're changing in order to see what the results are. All right, so to answer the question of if Gatorade makes you run faster, we set up a simple investigation. We had two people run a race, one had Gatorade, one didn't. That's an investigation, but it's not a very good one. So now let's talk about what we can do to make our investigation better. Let's say when we picked our two people to run that race, one of the people that we picked was Usain Bolt, and we're going to give him water, okay? And then the other person that we picked to run the race is this dude here, and we give him Gatorade. All right, we have him run a race. Who's going to win? Obviously, Usain Bolt is going to win. This guy would have to be in like a Ferrari in order to beat Usain Bolt in a race, because he has no chance of running faster than the world's fastest man. Now, if we run this race and we give Usain Bolt water and we give this dude Gatorade, Usain's obviously going to win. Can we then say that Gatorade doesn't make you run faster? Heavens no, because wasn't a fair race to begin with. It doesn't matter how much Gatorade or steroids you give this guy, he is never going to beat Usain Bolt in a race unless Usain Bolt is dead. That's the only chance he has of beating him. And so that isn't a very good investigation. And so that brings us to our next big idea. Our second type of variable we have in investigations are what are called controlled variables. And these are things that you keep the same between the things that you're testing in your investigation. So what you do with a controlled variable is you have your investigation and you try to make it so everything between the two things you're testing is the same except for your manipulated variable. You try to make it so the only thing that is different between the things you're testing is your manipulated variable. Now, an important thing to note about controlled variables, a good experiment should have at least 3 controlled variables. A good investigation should have at least 3 things between the 2 things you're testing that are the same. So let's write out a new investigation answering that question about Gatorade, and let's incorporate controlled variables. And the controlled variables will be written in red. So our investigation, we're going to start out, and rather than picking 2 people who are completely different, we're going to pick 2 runners who have the same time in the 100-meter dash. A good option would be twins. Now, I know they're a little old, but if you don't recognize these guys, these are Tiki and Ronde Barber. Okay, Tiki's over here and Ronde's over there. They're identical twins. They both played in the NFL. Tiki played for the Giants. Ronde played for the Buccaneers. Now, the reason why having these 2 guys run the race would be a good idea is because they have the same 100-meter dash time. They're identical twins. Physically, they're the same person. So if these guys run a race, and if everything's equal, they're going to run the race at the exact same time. If you give one Gatorade and the other one water, and let's say Ronde beats Tiki and he has some Gatorade beforehand, that's gonna be pretty good evidence that Gatorade is going to help you run faster. So we're going to pick 2 runners who have the same time in the 100-meter dash. We're going to give each of the runners the same running shoes and the same running clothes. That's something else that gets screwed up. Let's say we have identical twins, but we give Ronde cowboy boots and we give Tiki running shoes. Who's going to win the race? Well, Tiki's going to win because he's got better shoes. And so that would be another control variable we could put in there. We can make sure they have the same shoes and they have the same running clothes, so that way that's going to make them more the same. And then the other thing we could do is we could give them each the same meal for breakfast. Let's say we don't give Ronde any food and we give Tiki lots of food for breakfast before we run the race. That can have an effect on how fast they run. So this is what we mean by control variables. We put steps into our investigation to make it so the 2 groups that we're testing are as similar as possible. Now, after we've done all that, we can give one runner Gatorade before the race, the other runner water. That's our manipulated variable, and that's why it's in purple down there, to see what the difference is. So this would be a much better investigation because we've done more to make sure that our 2 runners are as similar as possible, so that way any difference between them is because of the Gatorade. Now, earlier I said in order for something to count as a scientific investigation or an experiment, there needs to be data. We need to be collecting stuff. So whenever you write an experiment, you need to make sure you have steps in there to collect data. Now, sometimes you don't need data. Here's Usain Bolt winning a race dominantly. There's no question who won that. Let's say your results are something more like this, okay? So let's say we run our experiment and he's got Gatorade and these fools all have water. Then we can easily tell the Gatorade made him run faster. But let's say it's something like this. Let's say this dude drank the water and this dude had the Gatorade. Really, really close results. And so we need some data to show that it's not much of a difference. Now, the data that we collect in our experiment is because of something that we call the responding variable. And the responding variable is what you're measuring in your investigation, okay? Now, every investigation should have at least one responding variable, but you can have many. There's no limit to how many responding variables you can have. There's also no limit to how many controlled variables you can have. You can put as many controlled and responding variables as you want to investigation. Manipulated variable is the only one that you only can have one of. You only have one manipulated variable, and that's it. So let's go through and let's look at our investigation again and figure out how we can put in a responding variable. So here's our steps. The red ones are our controlled variables. The purple one there is going to be our manipulated variable. Let's put in an extra step to represent a responding variable here in green. Our responding variable, have each runner run a 100-yard dash, time them with a stopwatch, and record the time. By adding that step in there, we now have data. So when you want to show people that Gatorade actually makes someone run faster, we can say, hey, the runner with Gatorade ran the 100-yard dash in 10 seconds. The runner without Gatorade ran it in 11. And so that would be data to show your point, okay? So all investigations need to have one manipulated variable, at least 3 controlled variables, and at least 1 responding variable, though you can have lots of them, because responding variable is going to give the data that you're going to use. Okay, so now we've set up our experiment, we've got all our variables, we've run it, we've got some data. The question then you have is, can you trust your results? Here's a famous play back a couple of years in football when they had replacement refs. And here you got one referee saying this is a touchdown, here you got one saying it's an incomplete pass. Who do you believe? Okay, they disagree with each other. Kind of the same idea applies to your investigation. Just because you did an investigation does not mean you can trust the results, because you could have messed some things up there to make it so your data is incomplete. We have a term for that, and that is called validity. Now, a good way to answer the question of validity is you're asking yourself, is my data true? How much do I trust it? Would I bet my life on this data? That's our question we got going on with validity. Is it true? Now, there's some ways you can improve your validity. And one of the easiest way to improve your validity is you can use better equipment. The better equipment you have, the more accurate your results will be, and the more you can trust your results. So an example of this, and we'll actually do this activity this upcoming week, is let's say I had you measure my classroom, okay? And I gave you different tools to do it. I gave one person a ruler, I gave one person a tape measure, and I gave another person a laser measure that measures distances using a laser. Which one of these results would you trust the most? Well, you're going to trust the tape measure more than you're going to trust the ruler, and you're going to trust the laser measurement more than you're going to trust the tape measure. So this is showing how better equipment can give you better results, which can increase the validity of your experiment. By having better equipment, you get more accurate results, which makes it so you're more likely to trust the results. Now, the other thing you can do to improve the validity of your results is add more controlled variables. There is no limit to how many controlled variables you have, and the more controlled variables you add, the better your experiment will be. So keep trying to come up with ways to make it so that the two different things that you are testing are as similar as possible. This is one of the reasons why identical twins are used so much in medical research, is because they're identical. They have the same DNA. By having two of basically the same person, that's a lot of controlled variables right there that are going to increase your validity. All right, the other thing we talked about that investigations have to have in order to be considered science is they have to be repeatable, that someone doing the same thing can get the same results. So the question you always have to ask after you do an investigation, if I do the same investigation again, will my results be the same? And we have a term for this. We call this reliability, okay? And a good way to think about reliability is, can it happen again? That if you do this, something will always happen over and over and over again. Now, the term we use reliable the most for is describing cars. This is a reliable car. This is a not reliable car. What makes a car reliable? It always starts. When you get in the car and you turn the key, it starts. A non-reliable car breaks down and doesn't always start. And so the reason why something like this is a reliable car is every time you get in it and start, it goes. Whereas other cars that are less reliable, different things happen every time you turn the key. That's what we mean by reliability. Will the same thing happen over and over again? And that's what we mean by reliability. So in this case of reliability, for our investigation earlier, reliability would be, let's say we run the investigation 10 times, and every time the runner has Gatorade wins. That would be reliable. But if you run the investigation 10 times and half the time the Gatorade runner wins and the other half the water runner wins, that's not a very reliable experiment because you're getting different results every time. Now, there are ways to increase the reliability of an experiment. And how we're going to do that is, one, we repeat the experiment several times. A good way of thinking about this is flipping a coin. If everybody in the room flips a coin once, half you can get heads, half you can get tails. You're going to get different results. But let's say we have everybody flip the coin 10 times. Are our results going to be more similar then? Yeah. We're going to have some people who are going to get 6 heads and 4 tails. We're going to have some people get 7 heads and 3 tails. But overall, the class is going to be more of the same. They're going to be close to each other because we repeated the experiment lots and lots of times. The other thing we can do that will increase our reliability is we can test more items. Okay. In the experiment that we wrote up, we only did 2 runners, and that's not a very reliable experiment. You want to use as many test subjects as you can. So if we did this experiment with 10 runners and 5 of them got the Gatorade, 5 of them got water, that would increase the reliability of our experiment, and that's something that we want to do. Reason I got this picture down here, and the reason why it cares if we can repeat something, this is something that happened at the University of Utah. They claimed that they invented cold fusion back in the 80s. They could never make it happen again. And so that shows why reliability is important, that if you can't make it happen again, you really haven't done anything. So to go ahead and wrap things up, you are going to be writing some experiments in this class. We're going to do this this upcoming week. What does a good experiment have in it? So every investigation should include the following. Here's what we got going on. Number 1, it should have step-by-step idiot-proof instructions. When you write an experiment, you cannot be precise enough. You need to give precise instructions for every step you got going on. An example of this is when I leave subplans, I tell the substitute how to turn the lights on in the class because I've had substitutes who don't know how to do that. And so you need to have step-by-step idiot-proof instructions. Next thing you need to have going on is you need to have at least one manipulated variable, one thing that you're changing that's going to be different between the groups you're testing. Your investigation should have, at least 3. That's controlled. Oh man, that's bad. Should have 3 controlled variables, okay? And at least 1 responding variable, and the responding variable is what's going to get your data. Now, the other thing we should have going on, there should be at least 3 things that you're testing, and you should repeat the experiment at least 3 times. So whenever you do an experiment, it should have all of these things, and if it has all these things, it can then be counted as science. So that wraps up our video on scientific investigations. In the next few days, you'll get some practice writing investigations and carrying them out.